Hello, welcome to Chapter 6, Section 6, Solving Systems of Linear Inequalities. Now, the reason why we are adding this section, it goes back, first of all, most of the hard stuff is a review of what you learned already in Chapter 5. We're going to be dealing with linear functions, which is a big component of this. If you look at what's already on there while I'm talking, you'll see, except for the less than and greater than symbols, a lot of this looks like the linear functions that we talked about. But another reason why we're going to do this is because it's a major component of the first quarter work that we're going to do in Algebra 2. So instead of you ended up in Algebra 2 never seeing anything like this and then getting doubly lost, then I'm trying to set you up a little bit so that when you do see it, you'll be a little more successful. At least you'll be able to say, hey, this reminds me of what we did in Algebra 1. So we're going to be graphing systems of linear inequalities. A linear inequality is let me break that down. Okay, the word inequality means that instead of things being equal, one side is going to be bigger than the other side. And we're going to be able to tell that by the symbols. So if I look at this symbol right here, it tells me that this side, whatever that value is going to be greater than that side. Over here, this one tells me that is greater than that. Of course, we always read it left to right, so we say y is less than negative x plus 4, but that means this is the bigger part. We say y is greater than, that line underneath it means or equal to, so it can also be equal to it, this part. Now, why are they called linear inequalities? Because when I graph them, there's going to be an area on the graph that makes this true. So we're going to have xy pairs that are going to make these inequalities true. And there's going to be a whole bunch of points with xy coordinates that are not going to make it true. And the separation between those boundaries, when we graph them, is going to be called the boundary line. It'll be a line. You can also have inequalities where the boundary is a different type of graph. But for these, it's going to be lines. So in this first video, we're just going to do something that we need to practice with. We're going to figure out if this ordered pair actually makes both of these true. So the first thing to notice is that if I say I have an ordered pair 2, 1, that tells me that the x is equal to 2 and the y is equal to 1. So I'm going to replace the 2 and the 1 with the x and y that I have in both of these, and if I get a true statement for both of them, then that means that it's a solution. This is very similar to when we were doing solving by substitution or solving by elimination. The second step, where after we get the value, we're able to put it into the equation in those problems and then figure out what the other one is. In this one, we're going to know what both of them are. We're going to see if we get a true statement. So start with the first one. I have y is less than negative x plus 4. I'm going to draw a line under that, and I'm going to draw a line down from the symbol, the less than symbol. My y is 1, so I'm going to put a 1 over here. My x is 2, so I'm going to say negative 2 plus 4. Now I'm going to leave that alone. I'm going to simplify this. Negative 2 plus 4 is positive 2. Now when we saw things like this before, we tried to make sure that they're equal. This time, I want this number to be less than that number, and that is true. So 1 is less than 2. Let's try it with the other one. So I know that the point 2, 1 makes the first one true. Okay, we're going to check that one off. That's true. But let's try it with the other one. Y is less than or equal to x plus 1. Same idea. My y is 1, and my x is 2. 2 plus 1 equals 3. So, is 1 less than or equal to 3? And it can be either one. So, 1 is less than 3. That's true. If they were both 1 or if they were both 3, the or equal part would kick in. The only thing that's going to make this not true is if this was bigger than that. So that makes both of them true, and we're going to say yes. 2, 1 is a solution to this system. Now, before I leave this problem and do the other one, I just want to be clear. There's an infinite, more than you can ever count, there's an infinite number of ordered pairs that are going to be solutions here. And we'll see that when we graph it. This just happens to be one of them. Let's try it with this. So for this one, x equals 2 and y equals 0. So you get y is greater than or equal to 2 times x. My y is 0. 2 times x is going to be 2 times 2. 2 times 2 equals 4. Is 0 greater than or equal to 4? No. So I don't even have to check the other one. I know this one is no, because it has to work with both of them. I can go ahead and show you how to do the other one. Y is less than x plus 1. Y is 0. X is 2. 2 plus 1 equals 3. 0 is less than 3. That's true. But again, it has to be true for both of them. Since this point is not in this system, or sorry, not in this linear inequality, then this point is not in the system. It has to be in both of them. Okay, we'll see you in the next video where we actually start graphing.